Why 90% of the deep sea glows in the dark. Imagine a world so profoundly black that a single match would look like a stadium floodlight. Now picture 9 out of every 10 animals living there, not just existing, but actively flashing, glowing, or flickering like living sparklers. That incredible, shimmering world isn't some far-fetched science fiction dream. It's our very own deep sea right here on Earth. And the mind-boggling reason why so many creatures transform themselves into living glow sticks? It's a life-or-death secret we're about to uncover. 90%, just let that number truly sink in. If you were to drop a net 3,000 meters down into the ocean's abyssal plains, a staggering 9 out of every 10 things you'd haul back up would have the astonishing ability to make their own light. In a place where the sun's rays literally never penetrate, where perpetual twilight gives way to absolute darkness, light isn't just a pretty decoration, it's the ultimate currency, a matter of survival. So why would any creature pay the significant metabolic cost of carrying a living flashlight, whether it's on its head, its belly, or even deployed in its own vomit? Stick around, because the answers are wild. They involve chemistry cleaner, then a lab coat, scams straight out of a crime thriller, and first-date signals more precise than Morse code. Venturing below a kilometer, the ocean transforms into midnight squared. It's a realm where temperatures hover near freezing, and the pressure feels like the crushing weight of a rhino balanced on every single fingernail you possess. Food, a scarce commodity, mostly trickles down from the sunlit layers above as marine snow, a continuous, gentle fall of dead bits and organic debris drifting like soggy confetti. In this extreme environment, where sunlight is an alien concept, traditional vision is almost entirely useless unless you're clever enough to bring your own bulb. So, evolution, ever the ingenious problem solver, held a design contest. Which life form could best turn this profound darkness into an unparalleled opportunity? The hands-down, undisputed winner emerging from the depths is bioluminescence, a chemical reaction so exquisitely fine-tuned it practically defines existence in the blackness. So how do they actually do it? Here's the elegant one-sentence recipe for nature's light show. A special molecule, aptly named luciferin, from the Latin for light bringer, meets oxygen. An enzyme called luciferase then steps in, facilitating a quick, efficient handshake between the two. The result? The reaction coughs out a packet of light, a photon, instead of heat. Because nearly all the energy escapes as visible light, not a warm glow you can feel. Scientists affectionately nickname it cold light. How efficient is this process? Try an astounding 96%. Your average desk lamp, in stark contrast, barely hits 20% efficiency. Most deep-sea animals brew their own luciferin and luciferase, manufacturing their light-producing compounds internally. Others, however, are a bit more resourceful, if not outright cheaters. They cultivate bioluminescent bacteria in specialized compartments within their bodies, essentially growing tiny tenants who pay their rent in lumens. Either way, the light they produce is almost universally blue-green. Why? Because these are precisely the wavelengths that travel farthest through seawater, making them the most visible in the ocean's vast, dark expanse. Red light, on the other hand, vanishes almost immediately, which is why some clever predatory fish have evolved to sport red searchlights of their own, invisible to nearly everyone else, but a perfect private hunting tool for themselves. In the deep sea, light isn't just pretty, it's a weapon. Take the deep-sea anglerfish, for instance. Picture a nightmare straight out of a horror movie, complete with a terrifying fishing rod welded right to its forehead. The lure at the end of that rod is actually a modified fin spine, packed full of glowing bacteria. Unsuspecting prey, drawn by this dangling beacon, mistake it for a tasty, easy planktonic snack. By the time they realize this plankton has fangs and a cavernous mouth, it's already game over. And then there's the viperfish, a sleek, saber-toothed torpedo that flashes like a disco stick in the mid-water column. It stalks its prey, lights up a dorsal ray like a neon sign, and when curious creatures drift in for a closer look, snap! Even the notorious cookie-cutter shark uses a cunning trick. It has a dark, unlit collar around its bioluminescent belly, which makes it mimic a much smaller, more palatable fish. This clever ruse lures larger predators in for what they think will be an easy meal, only for them to discover, too late, that they've just taken a very expensive, painful bite out of the cookie-cutter shark itself. Bioluminescence is also a fantastic way to say, "Don't eat me." Some shrimp, for example, have a truly gross but effective defense. They literally vomit glowing barf. This sticky, luminous mucus latches onto a predator's face, instantly turning it into a neon billboard screaming, "Eat me!" to anything bigger and hungrier in the vicinity. It's like a living, flashing target. Other creatures, like certain squid and deep-sea comb jellies, don't squirt dark ink. They fire clouds of bioluminescent ink instead. This dazzling, disorienting burst of light momentarily blinds or confuses attackers, giving the prey just enough precious time to jet away into the darkness. Then there are lanternfish, which adopt the opposite, more subtle approach. They have precise rows of light-producing organs called photophores on their undersides. These photophores emit light that perfectly matches the faint, downwelling light filtering from the surface, effectively erasing their silhouette from any predator looking up from below. It's a brilliant form of camouflage, like wearing an invisibility cloak tailored from moonlight itself. Finding a date in a world of absolute darkness? That's a challenge. But deep-sea species have mastered it, solving the problem with intricate, secret light codes. Female lanternfish, for instance, arrange their photophores in patterns utterly unique to their species. Think of them as glowing QR codes that males scan and interpret before they dare to risk an approach. It's a sophisticated who's who of the deep. Tiny crustaceans called ostracods, found in shallower waters, perform mesmerizing, spiraling light shows so incredibly precise that any male who deviates by even a millisecond is instantly rejected. Talk about high standards. Even bacteria get in on the communication act through a process called quorum sensing. Once enough of these glowers gather together, hitting a certain quorum, they all switch on their light in unison. This is why masses of Hawaiian bobtail squid, which host these symbiotic bacteria, glitter like buried treasure each night, a coordinated glowing display for all to see. Need more dazzling eye candy from the deep? The vampire squid, despite its fearsome name, is more of a gentle scavenger. But when threatened, it inverts its cape to flash a spooky, mesmerizing fireworks display. Deep-sea siphonophores, those incredible yard-long string-of-pearls predators, pulse with a hypnotic rhythm, looking like oceanic Christmas lights drifting through the abyss. And on the surface, dinoflagellates, tiny single-celled organisms, turn breaking waves into electrifying neon surf, a breathtaking phenomenon sailors once called the burning of the sea. Each flash, each shimmer, each brilliant burst of light is a microscopic reminder that biology, with its endless ingenuity, can consistently outshine any special effects department Hollywood could ever dream up. If learning why a fish would literally glue a flashlight to its face makes your day weirder in the absolute best way possible, then you absolutely have to tap that subscribe button. Join our ragtag crew of ocean nerds. We're dedicated to dropping videos that turn mind-blowing textbook facts into binge-worthy stories, and the best part? No scuba certification required. Here's one of the most astonishing facts about bioluminescence. It didn't just evolve once. This incredible ability has emerged separately at least 40 different times across the tree of life, with some studies even suggesting more. That's 40 distinct branches on the evolutionary tree independently inventing the exact same trick, a testament to just how overwhelmingly valuable light is in the deep, dark ocean. Fossil timelines suggest that glowing bacteria were likely the pioneers, appearing first. Then, over eons, larger hosts struck a mutually beneficial deal: free housing for free light, establishing symbiotic relationships. Over millions of years, this trait diversified from a simple, utilitarian blink to incredibly complex moving lures, sophisticated burglar alarms, and even encrypted love letters. In evolutionary terms, bioluminescence isn't just an adaptation, it's the ultimate Swiss Army knife of survival tools, constantly reinvented and perfected. In fish alone, it's believed to have evolved independently at least 27 times. It's not just deep-sea creatures benefiting from bioluminescence. We humans are catching on to its incredible potential too. Scientists now routinely harness luciferase, the light-producing enzyme, as a reporter gene in genetic engineering. When it glows, researchers know their genetic experiment, say inserting a specific gene into a cell, has successfully worked. Medical teams are using similar bioluminescent reactions to detect harmful bacteria in hours instead of days, drastically speeding up diagnoses and treatment. This can be crucial for identifying infections or testing antibiotic resistance. Oceanographers even track vast water masses by observing the subtle signature glow of plankton within them, effectively tagging the sea itself to understand currents and ecosystems. Every deep-sea flicker and flash holds immense promise, a potential breadcrumb leading us to new antibiotics, vital cancer markers, or critical insights into climate change. The abyss isn't just an alien world, it's an untapped, living library of technology and solutions waiting for us to decipher its glowing secrets. Despite all we've learned, the deep sea still holds countless glowing mysteries. We've cataloged thousands of bioluminescent species, but estimates suggest 1 million more remain undiscovered. That means almost every submersible dive still turns up creatures no human has ever laid eyes on, and often, their unique glow is the very first thing we notice. Why do some deep-sea worms sparkle only when touched by a particular metal ion? How do certain fish manage to switch their light organs on and off faster than a smartphone screen with such incredible precision and control? The ocean, in its boundless depths, keeps writing new questions much faster than we can possibly read, let alone answer them. It's a continuous, thrilling scientific frontier, illuminated by its own fantastic light. Got burning questions about glowing sea life? Drop them in the comments below. Seriously, no matter how bizarre or niche, odds are a brilliant scientist somewhere is losing sleep over the exact same thing. And hey, if you loved this video, hit that like button to help the algorithm shine its own weird, wonderful light on this fascinating topic. So to recap, why does a mind-boggling 90% of the deep sea glow? Because down there, in the crushing, sunless depths, light is everything. It's camouflage, communication, deception, and defense, all rolled into one incredibly efficient, breathtakingly beautiful package. It's the stark difference between eating and being eaten, between finding a mate and dying alone in the perpetual dark. The next time you casually flip a light switch in your home, pause for a moment. Remember that evolution invented the original, far more sophisticated version billions of years ago, no wiring required, with a chemistry set capable of outperforming even our best, most advanced LEDs. If that doesn't make you look at the ocean or even your humble aquarium with a fresh, profound sense of wonder, then honestly nothing will. And who knows? The next groundbreaking glow, the next revolutionary secret of light, might still be waiting in the crushing, silent dark, ready to rewrite everything we think we know about life on Earth.